All right, here's a new unit: deductive reasoning and inductive reasoning. Again, I like these because it's logic. It's about thinking. It helps you process how to think, which again is very useful. You have to think every day of your life. So again, this is very relatable to real life and trying to figure out unknowns, figure out patterns, find things that you maybe didn't know before. Now, I want you to notice something about, so inductive reasoning is when you find a pattern in specific cases and then write a conjecture for the general case. A conjecture is an unproven statement that is based on observations. So let's take a look. So one key thing to note about this is that we have alternating positives and negatives. So when you see that, because again, we can think a negative times a positive equals a negative. But then if I multiply that negative by a positive, if I multiply that negative by another negative, I get a positive. And then if I multiply that by a negative, I get a negative. And then if I multiply that by another negative, I get a positive. So when you see alternating positives and negatives, you can almost guarantee that you're multiplying by a negative number. So I see that 7 times 3 is 21. So negative 7 times negative 3 is positive 21. Positive 21 times negative 3 is negative 63. And negative 63 times negative 189 is negative 63 times negative 3 is positive 189. So in words, we're basically taking our previous term and multiplying by negative 3. But how do we show that in math terms? So there's a couple ways we can do that. So let's say that we're looking for the nth term. So we're going to say a sub n equals whatever a sub n was. I need to take my previous term, so n minus 1, and multiply it by negative 3. N minus 1. I could also write it like this, or I could say negative 3 multiplied by a sub n minus 1. So that's one way to show it. You can also, and it's very similar, you could say, hey, I'm looking for my next term. So I'm going to say n plus 1. I'm looking for the next term. So I'm going to take negative 3 and multiply it by a sub n. So again, just notice the differences is you can talk about n and then take your previous term, which is n minus 1, or you can find the next term and then use n to find the next term. Now, it is important that when you do sequences like this, you have to describe what the first term was. So a sub 1 equals negative 7. Again, thinking about if this is term 1, term 2, term 3, term 4, ... Now, if I look at this one, I see, okay, I have 1, 1, 2, 3, 5, 8. So it's kind of like I'm taking my previous terms and I'm adding them together. So if I want a sub n, I'm going to take a sub n minus 1 and I'm going to add a sub n minus 2. Because again, this will give me my most, even if I want the 100th term, I would take the 99th term and then subtract or add the 98th term. So if this is term 1, 2, 3, 4, 5, 6, again, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So using that logic, if I wanted to find this unknown, I could say, I'm going to take, let's see here, that's the 7th term. So a sub 7 equals a sub 7 minus 1 plus a sub 7 minus 2. Well, 7 minus 1 is 6, so a sub 6 plus a sub 5. And that's going to give me 5 plus 8. Should write it in the other order. 8 plus 5. And that's going to give me 13. Now in this one, I look 4, 8, okay, plus 4, plus 7, plus 1, plus 7. I can't really tell a pattern. I could try multiplying. I don't know. This one, I didn't know when I looked up at what as well. So I had to look on the internet, and these are apparently a sequence that occurred in the show Lost. And just by looking up on the internet, I made a conjecture because I found this sequence on the internet and they said the next term was 42. So again, it doesn't necessarily have a mathematical reason as to why the next term is 42. But hey, if you figure it out, I bet you could become internet famous. One way to disprove things is to provide counterexamples, which again, if you can provide one case where it doesn't work, then you can prove the whole thing to be false. So the conjecture, the sum of two numbers is always greater than the larger numbers. Okay, so again, so that's like saying x plus y is going to be bigger than whatever number is bigger. Let's say that it's y, and y is always bigger than x. Now, I can think of a classic example due to having a negative number. So let's think about it. X plus y, let's say that it's 4, negative 4 plus 6. Okay, 6 is greater than negative 4. That's a true statement. But negative 4 plus 6 equals negative 2. Negative 2 is not greater than 6. So a counterexample would be anytime you're using a negative number, the sum of the two numbers will not be greater. That's not true. Conjecture, all birds can fly. It's actually one of Mr. Larson's fears, but ostriches. Ostriches can't fly. Penguins can't fly. Okay? Those are just two examples of a counterexample where, hey, those are birds. They can't fly. Therefore, you cannot say all birds can fly. We can also apply deductive reasoning. So again, deductive is using facts and definitions, properties, laws of logics, and conclusions, whereas inductive is more like specific examples, finding patterns, and then making conjectures. So law of detachment, and we'll kind of dig into this, but if the hypothesis of a true conditional is true, then the conclusion is also going to be true. So make a valid conclusion in this true situation. Mary goes to the movies every Friday and Saturday night. Today is Friday. So my conclusion would be, therefore, Mary will go to the movies tonight. If she goes every single Friday and Saturday, then if today is Friday, she will go to the movie. Another law is syllogism. Syllogism. There we go. If A, then B, and if B, then C, then we can combine them and say if A, then C is also true. Again, these only work as long as these are true. These have to be true to conclude this. So write a new conditional that follows from the pair of true statements. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So we could say if Rick takes, so this is A, this is B, and then this is B, and this is C. So if Rick takes chemistry this year, then Rick will get an A in chemistry. And again, that's because Jesse is his lab partner. Hopefully they're not cheating, but maybe Jesse's just a great teacher and can help Rick. So let's look, determine whether we have inductive or deductive reasoning. Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. So if we go back again, do we have facts, definitions, properties, laws of logic, or conclusions? Do we have specific examples, patterns, or conjectures? I would say that this would be a deductive reasoning, or excuse me, this would be inductive reasoning because she's finding a pattern. Every time it goes up, it comes down, okay? Every time it goes up, it then comes down. So therefore, the next time Monica kicks up the ball up in the air, it will also go down to the ground due to the pattern that has been shown every time. She's making a conjecture. So I would say this is a conjecture right here. Whereas if we look at part B, all reptiles are cold-blooded, parrots are not cold-blooded. Therefore, Sue's parrot is not a reptile. These are based off of facts and properties, okay? That is a solid conclusion that you can make. So this would be deductive because it's based in facts.